Hello friends, Namaste. Welcome to this Chemistry Made Easy channel by Dr. ARM. Today we will discuss the next part of that VSEPR theory which we have seen earlier in the lecture. So last time we have seen some postulates and regarding the description by the scientist and development by the Gillespie and Newell. Then we have seen that the electron pairs present in the molecule around the central atom are having opposite action, that is repulsive forces are developed between the electron pairs of various types, and these pairs have effect on the shape of the molecule. So in order to see that, we will this theory tells us that the shape of the molecule depends upon the repulsive forces, and magnitude of repulsive forces depends upon the nature of electron pairs. So this can be arranged with decreasing order of their impact, that is magnitude of repulsive forces. So this is shown in this way. The lone pair repulsion between say two lone pairs is maximum. So the magnitude of repulsive forces between two lone pairs is maximum. Then the repulsive forces between one lone pair and one bond pair, then this is greater than the repulsive forces between the two bond pairs. So repulsive forces between two bond pairs are much lower, whereas the repulsive forces between one lone pair and bond pair is more, and the repulsive forces between two lone pairs is still more. So this is the order of repulsive forces. Now we will see some examples depending upon the molecules which are containing only bond pairs around the central atom. So we will see the examples of, so you can say A, that is molecules having only bond pairs. So there are several examples, but we will see only few of them. That is, the first is carbon dioxide, that is CO2. So according to this VSEPR theory, the steric number of this CO2 is 2. What is steric number? The number of positions occupied by the bonding atoms. There are two bonding atoms, that is oxygen to carbon. So two positions are occupied by these two bonding atoms, that is oxygen. And there are no lone pairs. So steric number is 2. Means carbon is at the center and the structure is like this. So this molecule shows that the bond pairs, these are bond pairs. There is no lone pair on this carbon. The central atom has no lone pair. So only the positions available in this molecule are 2, which are at extreme position, that is at 180 degrees. 180 degrees. So this molecule is linear. The shape of the molecule is linear. Now we will see the second molecule of this type, that is sulfur trioxide. Second molecule is SO3, that is sulfur trioxide. The steric number of this SO3 is 3 because the sulfur is bonded to 3 oxygens, means 3 positions are occupied by oxygens and there is no lone pair on this sulfur. So the steric number is 3. Now the structure of this molecule is like this. Sulfur is at the center. Then we will have the oxygens occupying these 3 positions in this way. So the 3 positions 1, 2, 3 around this sulfur are occupied by oxygens. Now we have not shown here the lone pairs on oxygen because these have no impact on the shape of the molecule. Now the bond pair, this bond angle is 120 degrees. How it is calculated? Because there are 3 positions around this 360 degree angle. So we can calculate 360 divided by 3, that is 120 degrees. So all these 3 atoms are lying at equal position from each other. So this shape of the molecule is called planar, triangular. Now we will see another molecule, third molecule. That is CH4. CH4. Here the steric number is 4 because carbon is directly bonded to 4 hydrogens and it has no more lone pair. So carbon is at the center. The hydrogens are occupying the positions in this way. This shape is called a tetrahedral. Tetrahedral. The bond angle between these two or any 2 hydrogens is 109 degrees 28 minutes. So this is a characteristic bond angle of a tetrahedral structure. But depending upon the influence of lone pairs or these nature of such atoms, the bond angle may change. But still it is called tetrahedral structure. Now the next molecule is PCl5. This has steric number 5, means phosphorus is bonded to only 5 chlorine atoms and phosphorus has no more lone pair. So the structure of this phosphorus pentachloride is like this. Phosphorus is at the center. These out of 5, 3 chlorines are present in one plane, that is XY. We can show this plane with these dotted lines. So this is XY plane and there are 2 more chlorines occupying the positions perpendicular to this plane. So the bond angle here is, so these 3 chlorines are occupying the total 360 degree angle around phosphorus. So 360 upon 3 is equal to 120. So this bond angle is 120 degrees and these chlorines in the direction of z axis and to this plane, the bond angle is 90 degrees. So this shape of the molecule is trigonal, bipyramidal, trigonal, bipyramidal. So next molecule is molecule is Sf6 Sulfur Hexafluoride. It has SN steric number 6 because sulfur has no more lone pair electron. Now the shape of this molecule is like this. Sulfur is at the center. There are 4 hydrogens present in this way in XY plane. So you can consider this x-axis, this y-axis, and there are 2 more fluorines in the direction of z-axis. So shape of this structure can be seen in this way. These dotted lines are showing the shape only. These are not bonds. So this is square planar shape, and perpendicular to this there are these 2 fluorines. So these are giving the shape called octahedral. Now the bond angles between any two are 90 degrees only. So you can consider the bond angle between 2 adjacent fluorines are 90 degrees. Now there is another molecule that is IF7, and this has steric number 7 because this iodine has no more lone pair electron. Now we will see the structure of this molecule. Since iodine is at the center, now the 3 fluorines are present in this way, occupying the 5 positions around this iodine in XY plane. So these are all equally distanced. Means distance between these 2 fluorines, these 2 fluorines, or these 2 fluorines, these 2 and these 2 are same. So these are shown in the same plane. Now we will see this shape of this. So this is pentagonal shape, and there are 2 more fluorines, out of which one is above the plane, second is below this plane. So the bond angle is like this. So the XY plane has, means this bond angle, you can calculate this bond angle in this way. So the total angle around iodine is 360 degrees divided by 5 is equal to 72 degrees. So the bond angle is 72 degrees between the fluorines, adjacent fluorines present in the XY. Now the bond angle between these fluorines, that is fluorines in the XY plane and fluorine present in the direction perpendicular to this plane, is 90 degrees. So there are 2 types of bonds, that is 72 degree and 90 degree. Shape of this molecule is pentagonal by pyramidal, pentagonal by pyramidal. Then next molecule is that is F8 3 minus. This F8 3 minus has steric number 8. Means there are 8 TAF bonds only. TA has no more lone pair electron. Now this structure is like this. Ta is at the center. Now we can show these fluorines in this way, occupying the positions like this. Now here also the positions like this, the fluorines occupying in this way. Now you can draw the lines showing the bonds. Now the shape of this, these are showing us the positions occupied by fluorines. So this shape is called square antiprism. Square antiprism. Then the bond angles between these two fluorines, that is adjacent two fluorines in this prism, is 70.5 degrees. Then the bond angle between opposite fluorines, we can take these two fluorines. So this bond angle is 109.5 degrees. So the bond angle between these two fluorines is 109.5 degrees. Means the two opposite fluorines are taken here. These two fluorines are adjacent to each other, so the bond angles are different. And now there is one more type of bond angle, that is the angle between one fluorine from one prism and another fluorine from another prism. It is 99.6 degrees. 99.6 degrees. And shape of this molecule is square antiprism. So in this way, these are only some examples which are presenting the effect of only bond pairs on the structure of molecule. So with this, we will stop here and we will continue the next part, where we will find that some molecules having bond lone pairs, and how they are creating effect on the structure of molecule. So till then, goodbye. See you next time. So please press bell icon button and like button and subscribe to this channel. Thank you very much.